Did you know that the concept of work in physics has a unique and fascinating twist? Imagine dedicating an entire day to studying, yet in the world of physics, you haven't accomplished any work. How would that make you feel? In the world of physics, work has a whole different meaning and is directly connected to how energy transfers from one object to another. In this video, we will understand the concept of work in physics, covering all the aspects related to it, including what is work, unit of work, work done when force is acting at an angle of displacement, and work done in various situations. In physics, work is defined as the measure of energy transfer that occurs when an object is moved by an external force along a displacement. It is the product of the force acting on the object and the distance it is moved in the direction of the force. So, when you push a box on the floor or pull a trolley, work is said to be done, as the applied force displaces the objects. But remember, in science, work is done when a force moves an object a certain distance. It is considered no work done if carrying a heavy load without moving it, even if it makes you tired. We will discuss it mathematically to understand why no work done is considered in this case. So, let us study unit of work. Work has different units depending on the system being used. In the CGS system, the unit of work is called an erg. 1 erg is the work done when a force of 1 dyne moves an object by 1 centimeter. But CGS system is not used oftenly. The most used system is SI system. In the SI system, the unit of work is called a joule. Now, what is the definition of 1 joule? A joule is defined as the work done when a force of 1 Newton displaces an object by 1 meter in the direction of the force. So, 1 joule equals 1 Newton times 1 meter, or 10 to the power 7 ergs in CGS. Now that we clearly know what is the basic definition of work in science, let us study work done by a constant force in detail. When a constant force, that is the force that does not vary with time, is acting in the direction of displacement, the work done is simply the product of the force and the displacement. For example, if you push a box with a force of 10 newtons and it moves 5 meters, the work done is 50 joules. It is now easier to comprehend why carrying a heavy load without moving, much like a statue seller who bears the weight of his goods on his head all day, is considered as doing no work according to physics. Isn't it unfortunate? Let's discuss why it is so. It is because since the goods are on his head and are stationary, they are not moving, therefore the distance covered is zero. Therefore, work which is force times displacement is zero. Moving on, what if the force is acting at an angle to the displacement? In this case, we need to consider the component of the force in the direction of displacement. The work done is the product of this component, F cos theta, and the displacement. Mathematically, this can be represented as W is equal to Fs cos theta, where W is the work done, F is the force, S is the displacement, and theta is the angle between the force and displacement. Now imagine a scenario in which instead of pushing the box horizontally, you decide to push it at an angle of 60 degrees upward from the horizontal direction. The box still moves 5 meters horizontally, but now the angle between the force and the displacement is 60 degrees. To calculate the work done in this case, use the formula W is equal to F into S into cos theta. Here, F is still the force, 10 newtons, S is the displacement, 5 meters, and theta is now 60 degrees. The cosine of 60 degrees is a half or 0.5. Therefore, the work done is W is equal to 10 into 5 into 0.5, which is approximately 25 joules. Work done can be positive, negative, or even zero depending on the angle between the force and displacement. Let's explore a few examples. Case 1, when work done is positive. When the angle between force and displacement is acute, that is, angle is less than 90 degrees, the work done is positive. Work done is maximum when the angle is 0 degrees, as work done is force times displacement times cos theta, and as the value of cos 0 is 1, hence, work is force times displacement only, which is the maximum work done, and it happens when the force acts in the direction of the displacement. Example: a gardener pushes a lawn roller through a distance of 20 meters, applying a force of 20 N at an angle of 60 degrees to the ground, which is an acute angle. The work done by the gardener is force times displacement times cos theta, that is 20 times cos 60, which equals to 100 joules, and it is positive. Case 2. When work done is 0. When the angle between force and displacement is 90 degrees, the work done is 0. As work done equals force times displacement times cos theta, and since cos 90 is 0, hence, work done is 0. Example: for a body moving in a circular path, the work done by the centripetal force is 0 since the force is perpendicular to the displacement. Some other examples are work done by a coolie carrying a load on their head, and the motion of the earth around the sun. Case 3. When work done is negative. When the angle between force and displacement is 180 degrees, as cos 180 is -1, so the work done is negative. This often occurs when dealing with friction. Example: a block is pushed by a force and displaced through a distance. The work done by the applied force is positive, while the work done by the frictional force is negative, as the frictional force works opposite to the direction of displacement, and hence the angle between the frictional force and direction of displacement is 180 degrees. In conclusion, the concept of work in physics is a fascinating and unique aspect that defines how energy is transferred between objects. It can be positive, negative, or even zero, depending on the angle between the force and displacement. Understanding this concept helps us to comprehend various real-life scenarios and the forces involved in them. We hope this video has given you a better understanding of the concept of work in physics. And remember, it's not just about physical effort, it's about energy transfer. Now that you have understood the important concepts of work, open the Eduriv app where you get video lectures, chapter notes, and MCQ tests for this chapter. Eduriv also provides you amazing courses for maths, social studies, English, Hindi, and many more.